Hi guys, today I thought I'd make a video about multimeters. So this is the Learn Electronics Repair Beginner's Guide to Using a Multimeter. Multimeter, very useful piece of kit. In fact, it's an essential piece of kit. To do any sort of electronic repair, there are two things that are essential to start with. You need a soldering iron with solder, and you need a multimeter. Yeah, without either of those two, you can't really do any sort of repair. So let's have a look at the multimeters. There's different types of multimeter, and they needn't be expensive. In fact, they can be very cheap, but there are expensive models around too. First distinction between multimeters are desk multimeters and handheld multimeters. Mostly we're using handheld multimeters for repair work, yeah, and I'm pretty sure that's what most of you, if not almost all of you, will be using as handheld, yeah. So given your handheld multimeters, there are two main types. There are the manual ranging. This is a manual ranging multimeter, and there are auto ranging. These two are auto ranging multimeters. The difference being that with a manual ranging, effectively you have to select a range. So a multimeter measures basically three parameters. It measures voltage, current, and resistance. Yeah, that's the main function of a multimeter. So with a manual multimeter, like this one is, if you want to measure voltage, you have ranges. So you have a 20 volt range, a 200 volt range, a 500 volt range. You can see there, yeah, 2 volt range and a 0.2 volt range. It's actually specified in millivolts. So effectively, to take a reading, you have to select the range yourself. With a auto ranging multimeter, you would just select, for instance, DC volts, yeah, and the meter will effectively select the range itself. You can set them to manual, and there's sometimes a reason to do that. For voltage is changing or not there for very long, by the time your auto ranging multimeter has measured, it's found the correct range and measured the voltage. By the time that's happened, the voltage has changed. Yeah, so there are times when you might want to set it to manual, but mostly auto is what you use. So in this case, again, on this multimeter, I'm having to select, for instance, like ohms, yeah, to measure resistance. And again, I need to select the 200 ohm, the 2 kilo ohm, 20 kilo, the various ranges. With this one, I just stick it to ohms, and it's automatic again, yeah, auto ranging. So if you're buying a multimeter these days, you should buy an auto ranging multimeter. We'll put this one on one side, but we might refer back to that a little bit later. For now, let's look at these two, okay? So this is a Fluke 79. Fluke multimeters are a premium brand. They're an extremely good brand. You buy a Fluke multimeter and it should last you a lifetime, really. I mean, I've had this one since about 1993, and it's still the meter I use every day. That's my everyday tool, yeah. This little one, an AN888. I got this off eBay or AliExpress. This is an inexpensive multimeter. I don't remember exactly what I paid for it, but it's less than 20 euros, somewhere in that range. I think it was less, maybe 15, something like that, yeah. This one, back in 1993, cost several hundred pounds UK. And to be quite honest, a second-hand one of these is still going to cost you somewhere towards £100, yeah, for a Fluke. So what I'm going to do is, because most of you are going to be using something like this, we'll use this one to do the video today. Yeah, again, we'll keep this one on one side. We might want to refer to it, but we're going to do all the tutorial with this one. So this is an AN888. Inexpensive multimeter. One reason I bought this is because it's very small, so it's much easier to take on site with me than the bigger one. That's how the display got a bit scratched, by the way. The second thing I liked about this multimeter is that it has a backlight. Working on the workbench, that's not a problem. It's nice for the YouTube video, but when you're working out on site, that is extremely useful, yeah. So that was the other reason I bought this one. So, multimeters, as I mentioned, they have three main functions: voltage measurement, current measurement, and resistance measurement, yeah? So, let's start off with voltage measurement first. You'll see on this one, are two connections, yeah? Let's zoom down a little bit and you can see it a little bit better. Okay, I say the two connections. There are three connections, yeah? One of the connections is marked common, and this is where you attach your black lead, yeah? Your black meter lead, and it's even marked black inside there, yeah? So that is your common, and that stays there. Then you have two others, yeah? This connection, it specifies as for measuring volts and ohms and a few other things. This does microamps, and we'll come to these other features a little bit later. So that's that one, yeah. This one is for measuring current, amps and milliamps, yeah. And that's common on multimeters. If we just look back at the first one, the manual ranging, the common's over here. Again, volts, ohms and milliamps here. And if you want to measure high current up to 10 milliamps, it's there, yeah. The fluke, again, common here, so the black always stays here. This is volts, ohms, yeah. This is for low current up to 40 milliamp, and this is high current up to 10 amps. And you'll notice this has it's fused. So this has a fuse built in, and if you pass too much current, it will blow the fuse. It will save your meter from any damage, but you won't be able to measure current again until you replace the fuse. Okay. Back to the little aneng, and much the same. You'll see this current is fused, yeah. Voltage is telling you the maximum voltage you can safely measure, yeah, and the same on the other ones. So let's have a look at voltage measurement first, how we use a multimeter to measure voltage. Okay, so put the light on, there we go, just because it looks nice. So measuring voltage. Here we have a simple little circuit I've made. So we have a 9-volt battery, yeah? The positive from the battery coming in, there's a resistor to an LED and the negative. So that is your circuit from positive through the resistor through the LED to negative, yeah? And if we connect the positive wire, this is called a breadboard, by the way. So if you've not seen one of these before, basically each row of these pins is connected together with metal clips inside. So each row effectively connects between all 6 of those points, yeah? And then the next row, and the rows are isolated from each other, but each row connects to 6 points. And we can push wires into them, yeah? So the top ones, V2, V1, the black goes across all, so it's like one row of clips, and then you've got 2 input voltages, 1 and 2, yeah? So all those 12 connected, and all these 12 connected. Oh, and there's 3 and 4 down here. So that's your breadboard. So we've made the circuit now by connecting the positive to the resistor through the LED, and the LED is lighting up. When you're measuring voltage, by convention you put your black lead on the negative end of the battery or the power supply, or the ground, the 0 volts, yeah? And that's your reference, and that stays there. So if we want to measure the voltage coming from the battery, push the wire into the hole, and finally don't go to the hole very well. Let's connect to the leg of the LED. That's going to the negative, yeah. This positive. This is going into the resistor. So we can now see there's 9.46 volts coming out of the battery, yeah. If we want to measure the voltage across the LED, we can come to the other end of the LED, and there's 3.05 volts. So that tells us that there's 3.05 volts across here, and there's 9.4 volts across the whole circuit. And if you're wondering where the other sort of 6 volts is, it's across the resistor. Yeah. But generally speaking, you keep this on the ground. If you measure voltages this way, when you maybe on the internet, you're on forums, you're explaining to people, they'll understand what you're measuring, yeah? They'll understand how you're measuring it, and they'll understand what you're doing. So that's how you measure voltage. One end to the negative, and the other end to wherever you want to measure the voltage of the LED, the voltage of the supply. So measuring voltage is very simple. The same applies, by the way, if you have a manual ranging meter, but on this you'll see that we have to, if we set it to 20 volts, because you know it's a 9-volt battery, negative, positive, you read 9 volts, yeah. What happens if you select it too low, 2 volts? It just goes to 1. That means there's too much voltage. If we go up 1, back to 9.4. So you see, that's not damaging the meter by selecting the wrong range, it just goes over the range, yeah? When you then select range within range, you can use it. It's 9.4. If we select 200, 9.4 with 1 decimal point. If we go to 500, it should just say 9. Yeah? But it's not so accurate. It went to 10, in fact. Yeah. So that's how to use on the manual ranging. But I hope you're going to be using one of these auto ranging meters. Okay. So that's how you measure voltage. That's the first function of a multimeter. Just take the battery off there. Okay. The second function then is, with the lead still in here, is measuring resistance. Yeah. So again, this is an auto ranging meter. So ohms, a little horseshoe sign. Ohms, that's resistance. Yeah. So we can go to ohms, and you can see it's on auto and it's on mega ohms. It's showing us there. Yeah. To measure resistance, again, you just measure directly across the resistor. It doesn't matter which way you measure, and you do this with the power off. Yeah. So we can measure across here, and it's changed the range down to ohms. It says 333. And if we look at this resistor, it's orange, black, which is 330, so it's a 330 ohm resistor. And whichever way I measure across the resistor, I will see the same. Okay. If we take another resistor, this one's a 1 kilo ohm resistor, so it should be 1000. Get a connection with it. Do it this way. Yeah. 994. It generally, on low value resistors, you can do this, and it's reading basically the same. Yeah. But your fingers have some resistance. Look, if I connect my fingers like here, I've got 1.5 mega ohm. So if I'm reading very high value resistors, I'll get an incorrect reading. But for low, you know, you can do it that way, or you can just hold one end and just touch the other end. Yeah. Once again, I mentioned it, manual ranging. You can do the same, but you have to choose a range. So choose a 2000 ohms range. Doesn't matter which way you measure it. And then I find it doesn't work on this meter. And then I find that I have to use the correct meter probes. Yeah. Use the correct meter probes. See, again, it's reading the resistance. I can go to a lower range, and it'll just say 1 was out of range. Yeah, I can go to a higher range, it'll still read it, but just for a lower precision. 0.98 kilo ohms. Yeah, 1 kilo ohm. So manual ranging. So that's really how you measure resistance. It's very simple, and it doesn't matter which way you measure across the resistor, in circuit or out of circuit. If you measure resistance in circuit, if the resistance reads correct or less than the resistor's markings, it may well be okay. The reason it may well read less is because there'll be something else in the circuit connecting across it, another resistor. Yeah. If it reads higher than the rated value, then that is a faulty resistor. There's no matter what was connected across it, it can't read higher than the rated value. Yeah. So that's checking resistors. Okay, so resistors is easy to do. Let's have a look at current. Current's a different matter. We can put this onto the milliamps and amps range. Yeah? Again, it's an auto ranging meter, so we don't have to worry about it. We can choose amps and milliamps. Yeah, and we can now measure current. But how do we measure the current in this circuit? Well, you can't measure across a device to measure current. The only way to measure current is to put your meter in the circuit. Let me draw that for you, and then you'll see what I mean. Okay, so here's our LED circuit, yeah? And what we have a battery, plus 9 volts, yeah? We have 0 volts, or the negative end of the battery. And then we have here an LED. We have a resistor, and that's the circuit. Okay. When we make the circuit, when we connect the battery, the LED lights up. Yeah. The current flowing in this circuit depends on the value of this resistor. Yeah, so the lower the resistance, the more the current. If you make the resistance too low, then the current through the LED is too high, and the LED will burn out. Okay. So to measure voltage was simple. We always connect the black lead to the negative end of the battery or the negative end of the power supply, the chassis ground. Yeah, and we have our multimeter. And then the positive lead we stick wherever we want to measure the voltage, yeah? And that's how we're measuring voltage. And we can measure the voltage here, which gives us the voltage across the LED was about 3 volts. We can measure there, which gives the voltage across the battery was 9 volts, yeah? And that's how we measure voltage. To measure resistance was the same. We disconnected the power and just measured directly across the resistor. So those are quite easy to make those. So we can have no power, always resistance without power, yeah? The switch is open, there's no power, and now you can measure resistance across the resistor, yeah? And that's your resistance. To measure current is a little bit different. We have to insert our meter in the circuit, so somewhere we need to break the circuit, yeah? And we can do it like this. So our multimeter, yeah? So we need to do something like that, yeah? The current flow in the circuit is the same through the entire circuit. So now, the current that's flowing through the LED, the current through the resistor, and the current through your meter is the same, yeah? Therefore, think about it. When you're measuring voltage like this, your meter has to have a very high resistance because you don't want to interfere with the circuit. You don't want to connect a low resistance across this LED, otherwise the LED will go out. So your meter is a very high resistance. When you're in current range, your meter is a very low resistance because you don't want to interfere with the current flowing. If it's at a high resistance, you'd reduce the current, the LED would go out. Yeah. So this comes to an important point. On the voltage range, if you choose too low a voltage range, it'll just say 1. It's out of range, you select a higher one, yeah? If you connect your meter like this, and you choose the microamps range, or the milliamps range, and your meter has a fuse built in that blows at, say, 20 milliamps. If the current is above 20 milliamps, you'll blow the fuse inside the meter. You can change the fuse, but have you got spare fuse? Yeah, you need your multimeter, yeah? So that's the same. If you on very high currents, you have a 10 amp range. If your meter is drawing more than 10 amps, it'll blow the fuse in the meter again, yeah? If you have an unfused multimeter, it'll burn your multimeter out. So that's another thing we'll mention in the end about how to select a multimeter. Okay, I'll just mention this current. It doesn't have to be like that. I've seen other videos on YouTube tell you connect it like that. It doesn't matter. You can do this. Yeah. You can do this. You can even do this. Okay? As long as the meter is in circuit somewhere, all these three will read the same current. And the current they read will be determined by the value of this resistor. Yeah? So that's how you measure current. So now you know how to measure current. Let's do it, yeah? Let's measure the current of our circuit. And I'll do it the different ways to show you that it's the same, yeah? So, first of all, let's break the circuit here. So we're disconnecting the resistor, yeah? So what we're basically doing now is this. Sorry, this, yeah? We're inserting the multimeter between the battery and the resistor, yeah? So there's the multimeter. We're going to choose current range. On here is, I'm on it, amps and milliamps, yeah? Amps and milliamps. We're going to connect the battery. And obviously the LED, it doesn't light up because we broke the circuit, yeah? And we're now going to connect, if I can get a connection from here. If I can get a connection, and you can see the meter from here to here. I have a connection, and you can see 19 milliamps, yeah? 19 milliamps, okay? So that's the current. As I just explained to you, it doesn't matter where you measure the current. So if we connect this here, and we disconnect the other end of the resistor, and we now put our meter in the circuit here, we'll get the same. Red lead towards the positive, black towards the negative. 19 milliamps. If I connect the leads the wrong way round, by the way, it'll say minus. It'll still work. Yeah, but I think see on the meter now it's saying minus, yeah, because the current's flowing through the meter the opposite way. Conventionally, we would connect the red to the positive side of the circuit, yeah, but it doesn't matter. It'll work the other way. It'll just say minus. Yeah. So we can connect this back up again. And again, the last place we'll put this in the circuit is in the negative, yeah. So we're now going to do this one. Yeah, we're doing this one. Okay. Black to the negative ends because it's the negative of the battery, and red. Get connection. 19 milliamps, yeah. So you can see that no matter where you put the meter in the circuit, you get the same current. Because the same current is flowing through the entire circuit, including your meter. So that's how you measure current on a multimeter. Okay? Those are the three main functions of a multimeter: current, voltage, and resistance. But a multimeter has a few other useful features as well. This one has continuity mode, and all multimeters have a continuity mode. So to select continuity on this one, it's now in megohms auto, yeah? I press this till it goes to the bleeper. By the way, the light times out on this after a certain period of time so you don't drain the battery. It's now got a little speaker symbol here and an ohm sign here. It's now in continuity mode, yeah? If I touch the leads together, and connect them to the right place, of course, voltage ohms, yeah? The light goes out and it bleeps. Yep. This is very useful if you're trying to trace a circuit where you want to know if two things are connected together. So if I go to a resistor on continuity, it won't actually show anything, yeah? If I connect to the same wire at a different point, you notice it bleeps even before the display changes, yeah? If I leave it on there a little while, you'll see it reads 0, well, near enough. But it bleeps instantly. That's important. You need to have a multimeter that has an instant response. Yeah? If we go to the fluke continuity mode, yeah? This one, instant, yeah? If you hold them for a little bit longer, it'll read, but just touching is instant, yeah? The cheap manual ranging one has an ohms range, but it doesn't have a continuity tester. It doesn't bleep, yeah? It'll tell you it's 0 ohms, but it won't bleep. This is no good for short circuit finding. It's just not. You could use it, but you won't want to use it. Yeah, get a multimeter that bleeps and make sure it bleeps instantly, not a tenth of a second later. Yeah, that matters when you're working. Okay, so that's continuity mode. Your multimeter also will have a diode test mode. This is very useful. So on this one, we hold the select button in, we have a diode symbol, yeah? Can you see that there? Diode symbol. It's now in diode test mode. Now this is interesting, in this mode it doesn't bleep. The light goes out but it doesn't bleep, yeah? What this does, if you see, It's not saying ohms now, it's saying volts here. Let me zoom down, you'll see it. Okay, so I've zoomed in, so you can see now there's a diode symbol here, yeah? If we touch the leads together, the light goes out, it reads 0, yeah? But it doesn't bleep on this meter. That's a bit of an inconvenience. If I use the fluke on diode test mode, on this one I hold this button until it bleeps twice. And you'll see it's now saying volts DC, yeah? This is diode mode. Touch them together, this also bleeps. That's very handy, really. On diode mode it should bleep, yeah, when it's reading 0. Let's look how diode mode actually works. So this is the diode. It has an anode and a cathode. It conducts current one way. Yeah, can you see there? Yeah, you can see that it's got the diode symbol. Yeah. So anode, cathode. So positive to anode, negative to cathode. This could conduct. Yeah. And the meter is now reading the forward voltage drop across that diode. So diode mode works by measuring the voltage drop. Yeah. 481. If I go the other way around, it won't conduct. So this is how you use a multimeter to test diodes. Now watch what the fluke does. Watch what the fluke does. When I connect across there, positive, to here we've got a bleep. Just a bleep, not continuous, a bleep. So without even seeing the display, that's the forward voltage drop, I know straight away I've got a diode junction. Yeah, if I touch them together, get a permanent bleep. This is very, very useful when tracing circuits. It's a downfall of this meter. It's one thing it doesn't have that it should have. Yeah, if you're buying a meter, that's something you really want to be looking for. So it bleeps on the diode junction and continuous on a short. Yeah, that'll save you a lot of time circuit finding. And let's face it, fault finding. Fault finding in circuits is a difficult enough job in the first place. Never mind if you haven't got the tools which are helping you the most. Yeah, so that's that. What else does a multimeter do? It has a few more esoteric things, yeah. A lot of them will measure capacitance, and this has a capacitance range. They both do. But again, this is the sort of thing most likely you will have, yeah. So on this, we find capacitance range, which is in the same place: ohms, diode, bleep, capacitance, and we have to hit select until it goes to ohms, diode, capacitance. It now says NF, nanofarads in the corner, yeah? We can now use this to measure capacitance. So here's a capacitor. $330, $340. It's actually a 270 nanofarad, but capacitors are usually not that close. Look, without my fingers across it, 295, yeah? And it should be a 270. That's within tolerance, yeah? We can also measure large capacitors on here. This is a 1000 microfarad electrolytic. What you'll notice with this is when I connect to it, let me just get a good connection on it. Put the light on again for you. Yeah. Yeah, it takes a few seconds when you do this. It will do it though. So I'm connecting to the capacitor. I'm across the capacitor. Wait, it's changed to microfarads. 982. Yeah, 990. So you can see it will measure capacitors, large ones, but it takes a little bit of time. Yeah, but it's a useful thing to have that on there. The other thing on this multimeter you'll notice, it has a squiggle and a line. Yeah, the line is DC and the squiggle is AC. So on this you can see when you select volts, millivolts, microamps, milliamps, amps, it automatically, whether you put AC or DC in, it will work. Yeah, it does it. Whereas this type of multimeter, the manual one, you actually have to go to, this is volts DC with the line and the dots, yeah. And if you want volts AC, it's here. And look, on AC voltage, it only has a 200 and 500 volt range. It doesn't have the low voltage ranges, yeah. Also on this one, this is your current ranges, and the current ranges just are just DC. this doesn't have an AC current, whereas this does, yeah? That's another good reason. The Fluke, just out of interest, is a little bit different. This has its own AC voltage range and DC voltage range, yeah? And this has a DC amps and AC amps range together. So, you know, this will vary a little bit from one multimeter to another. This also has the capacitance range, yeah? One other little feature both of these have is frequency range. Hertz, yeah? Hertz on here and hertz on here, yeah? I'll show you the rough of the frequency range, how it works. And this meter in particular also has here a square wave out, yeah? So this one, you can actually choose an output and send a signal out, and again hertz is on this terminal, yeah? This is only amps and milliamps, nothing else. So on this one, for example, we can put a frequency, yeah? 400 hertz, yeah? And that's sending the signal out of here now. And if I take the Fluke, give you some light. If I take the Fluke and we go on this one to hertz, yeah, and we connect it to the other one, in fact you can see it, 400 hertz, yeah. So whatever frequency I send out of this goes up to about 4 kilohertz, yeah, 4 kilohertz, 5. Yeah, 5 kilohertz is the most it goes to. Yeah. I've never used it. Yeah, I'm sure there might be some reason why I want that. Audio circuits to inject the signal might be quite nice. But yeah, so you also find some facilities like that. But these are bonuses, yeah. So what to look for when you're buying a meter? Well, first thing is really, is it auto ranging? This isn't, so don't buy it, yeah. These two are both auto ranging. This one, I say, is not expensive, maybe 20 euros or something. It's a very good meter. The only thing I can say that this doesn't have is the bleep on the diode test mode. If I was buying one now, I would definitely look for that facility. This also has a facility whereby the backlight turns off after a period of time, yeah, but the meter stays on. It may turn off eventually, but I'm not sure how long we have to leave it for. But that's to stop you draining batteries. This one, the Fluke, actually goes to sleep completely. So if you leave this switched on and you go home, you know, or leave it for half an hour over lunch, it just goes to sleep. This is very good for batteries. I mean, I think in 27 years, 28 years, I've perhaps changed the battery 3 times in this. Yeah, I haven't used it continuously for that time. I mean, there was probably 10 years when I didn't really do this sort of work. Yeah. The other thing then, so yeah, if I was buying one now, if you can afford it or get a second-hand one, you will not go wrong with a Fluke. You really won't go wrong with a Fluke. If you're not in that price range, yeah, because a second-hand one is probably £50 to £100 upwards, yeah, and usually very expensive. If you're not in that price range, something like this, it's a great little meter. I would try to find one that has the bleep on the diode test mode, because that's the only thing I can say against this, yeah. Last thing, if you're buying a meter, it will come with some sort of meter probes, yeah. It will come with some sort of probes. But most of the probes these come with are pretty useless, they're rubbish, yeah. So when you buy a meter, make sure you get some decent quality test leads. And by decent quality, I mean sharp ones, yeah. Needle sharp. I mean these will, you know, they're needle sharp, yeah. That one does get a bit worn now, but get good quality test leads. And every year, when they start getting blunt, replace them. They're not expensive. Replace your test leads when they're getting worn. Yeah, keep a spare set, because when you break, they just break without any warning. Yeah, you'll break them. I mean, this one, for instance, the negative is broken. Yeah, so you know, keep a spare set. The other things I'd say find useful to buy are a couple of leads like this. So it has one end which goes into the meter, and then there's a clip, yeah. A couple of them are very useful. And again, they're not expensive. Make sure you get nice flexible ones, yeah. And they'll last you years. And buy yourself a set of leads like these. You probably get like 5 or 10 in a pack. They're crocodile clips, or yeah, alligator crocodile clips. A few leads like these, because these are very useful when you're working on something. You might just want to clip one end onto your test meter, yeah, and then clip it onto something like this, yeah. So a couple of them. There's also a matter of safety that we need to talk about as well with the multimeter. I mean, in a lot of cases, you're going to be working on low voltage circuitry, so there really isn't any particular hazard as long as you use the meter correctly. But what you need to be aware of is when you're on high voltage circuits, yeah. And there are a couple of factors. First of all, is your meter probes. I mean, these particular ones are actually specified, they say on the 1000 volts max, yeah. So you need to be sure that your meter probe is rated high enough for the highest voltage you want to be measuring. These safe up to 1000 volts. Also on these, they specifically say 20 amps, so that's the maximum current. So for safety, you need to make sure that your meter probes are rated to the voltage you want to measure. Secondly, these have like a ribbed part here. You need to keep your fingers back here, yeah, when you're working with it. You don't want your fingers down here, yeah. Your fingers back here, yeah, at all times, even on low voltage stuff. Stay safe. Then if you do it on low voltage as well, you don't have to think, oh, I'm on high voltage, I need to do this. Just do it all the time, yeah. So that's the first thing. Make sure that your meter probes are in good condition, that they're not split, that there's no bare wires showing, yeah, because that's dangerous. They need to be in good condition. That's the first thing as well, safety. The other one is the use of the meter. We mentioned how to measure voltage, how to measure current and resistance, yeah. So resistance measurements with the power off, yeah. You can damage the multimeter if you're trying to measure resistance when there's voltage present, especially high voltages. So measuring resistance, power off, batteries disconnected, and if there's large capacitors, make sure they discharge, or just leave it a little while till they discharge, yeah. The other thing is measuring current. One moment. The other thing you need to consider is when you're measuring current, yeah. So I mentioned earlier in the video that basically your multimeter, when you're measuring volts, is a very high resistance. So when you're connected across, for instance, this LED, very little current, microamps, are flowing through the meter. Resistance is very high, so it's not affecting the circuit. You know, the LED still lights up, yeah. When you have your meter connected onto amps, it's a very low resistance because the current has to flow through the meter, and the meter has to have effectively no resistance to give an accurate reading, yeah. So it's extremely low. So the problem here occurs, for example, if we have a circuit like this, yeah. So we've got a transistor, for example, yeah. 0 volts, and it's switching some sort of, well, yeah, let's not have a resistor. Let's just have a circuit like this, yeah. So transistor with an LED plus volts, yeah. And this transistor is driven by a square wave, yeah. So it's switching on and off very rapidly, yeah. And by altering the width of the pulses, the controlling circuit can control the current through the LED. So the narrower the pulses, the less current, the wider the more. And it can be working at such a point that there's never too much current flowing through this LED, yeah. So even at the maximum pulse, say it's 50%, this might be passing like, say, 20 milliamps, which is what you want for the LED on the bright, yeah, and make the pulses narrower, it goes dimmer. If you now come along with your multimeter on current range and you want to measure the current through this LED, yeah, and so you come along and just effectively try to measure current like this or this, there's a very good chance you can, because you've effectively shorted out this LED now, you might blow the transistor, yeah. If you think, oh, I'll measure the current like this, I want the current to flow through the transistor, as soon as you do this with your meter, you short this out, yeah, and this LED just burns out. So there's that problem, yeah. So you have to be careful when you're measuring current, because you're attaching a very low resistance device to the circuit, and that's why it has to be, you have to break the circuit and fit it in, yeah, meter like that, as I was showing you. But you should ask yourself as well, if you don't know what the current is in the circuit and you have depending on your meter set to milliamps or microamps, if it's fused at say 40 milliamps maximum, when you connect your meter correctly, as I've shown you, you can blow the fuse in the meter. The other thing you need to consider is, do I have to use current range to work out what the current is in the circuit? Now the answer to that will depend on the circuit, but in this case of the one that we were using with an LED, the answer is no, you don't. So if we go back to our original circuit with the LED, we had the 9 volts battery here, we had a resistor, we had an LED to 0 volts, yeah, and the LED was lighting up. And we measured with the black probe to here, and we measured to here, we know we had 9 volts, yeah? And we measured the voltage across the LED, and we also measured the voltage across the resistance. And the voltage across the resistance was 6.4 volts, yeah? That's measuring with, doesn't matter either, you'll say plus or minus, but red to the positive end, 6.4 volts, yeah? So we know there's 6.4 volts across the resistor. We also know that the resistor is 330 ohms, yeah? So we can use Ohm's law. We don't have to use our meter on current range. We don't need to break into the circuit. We can work out exactly what the current is because you have Ohm's law. And although we don't have any maths on this channel, Ohm's law, VIR, is the only bit of maths we ever have, yeah? Volts equals current times resistance, yeah? Now you want to know the current. So current, I, equals voltage over resistance, V over R, yeah? We know what a volt is, it's 6.4. And we know what R is, it's 330 R. And if I go online now to my calculator, which I won't bother, well, I can do it on my phone, but I won't bother. If I divide 6.4 by 330, I come to 0.019. And that's exactly what we measured, 19 milliamps. Yeah, do the math yourself, it's correct, yeah? So, we don't actually have to use current mode. And in a lot of cases, that's true. Not in every circuit. Sometimes there's where you don't have a suitable resistance to measure, you can't. But in this case, you can. And in a lot of cases, you can, yeah? So, before you use your meter on current mode, first of all, think, what am I doing? Am I shorting something out? Because I'm now putting a short circuit in, yeah? Don't measure across the device. You need to break in the circuit. If you're going to break in the circuit, you need to have an idea of what the current is to start off with, or set it to the maximum range and come down. This one's an auto ranging and it's fused at 10 milliamps regardless, so with this one you're unlikely to blow a fuse, yeah? Thirdly, think, can't I just do it the other way? Measure across the resistance in the circuit, yeah? And that'll work out the current. Okay guys, so that's the end of the little multimeter video, and I hope you enjoyed that. And I'll see you very, very soon on the next one. See you now.